Hello guys, welcome back to my YouTube channel. Today we are just going to discuss about database management system, that is DBMS, in which we are discussing about today's topic is functional dependencies. First, let us see the definition of functional dependency. Functional dependency is a set of constraints between two attributes in a relation. A relation is nothing but a table. Okay. Functional dependency says that if any two tuple is nothing but a row. Okay, please remember the terms that relation is nothing but a table and tuple is a row in a table. Functional dependency says that if any two tuples, that means that any two rows have the same values for attributes a1, a2 and an, then those two tuples must have same values for attributes b1, b2 and so on bn. That means we can write it as simply if tuple 1 of x equals to tuple 2 of x, then tuple 1 of y also will be equal to tuple 2 of y. This is the condition for a relation is said to be a functional dependency or not. Okay, functional dependency is represented by an arrow sign like you see in this bracket, that is x determines y. We will spell it as x determines y. That means where x is being determined by y, where x is determinant and y is dependent, we will call x is a determinant and y is a dependent, and we will read this statement as x determines y. Okay, let's see the types of functional dependencies. We have trivial and non-trivial. There are two types. Let's see trivial. If a functional dependency x determines y holds, that means if x is determining y, where y is a subset of x, then it is called trivial functional dependency. Trivial functional dependency always holds. That means it always holds that x determines y is always true. Non-trivial, if for a functional dependency is x determine y holds, if this exists, then where y is not a subset of x, then this is called a non-trivial functional dependency. That means what is the only difference is when x determined y holds, that means if x is determinant on y, then we can say that as y is a subset of x. So this particular rule applies. If this particular rule applies, then we will call it as a trivial functional dependency. If it is not a subset of x, then it is called as non-trivial. Okay, now let us see about some rules which Armstrong's axioms, we will call them as also. We will call it as also Armstrong's axioms or interface rules. Okay, I'm discussing the rules as well as providing you the notes of it so that you can study it for theory exams also. So let us see the functional dependencies consists of 6 types of rules. Okay, let's see. The first one is reflexive rule. In this rule, if y is a subset of x, then x determines y. You can write it as this way. That means let us see for an example. If x contains a, b, c, d, e and y contains a, b, c, here y is a subset of x, right? Where x is not a subset of y. So if y is a subset of x, then we can say x determines y. So this rule is satisfied whenever the value of that means the y is a subset of x. So then we can say x determines y. Second rule is transitivity rule. In this rule, if x determines y and y determines z, then x must also determine z. Let us see in the expression form so that you can understand it even more better. If x determines y and y determines z, then automatically x determines z. See, this is the rule of which is transitivity rule. You have to remember all these rules are very, very important. You can apply it in anywhere in the problems also. And the question also is very important. Augmented rule. In this rule, if x determines y, then xz determines yz for any z. That means if x determines any y, then xz determines yz is also exists, it seems. This is nothing but z is applied on both the sides. So if this exists, this also will exist. That is the rule, which is augmented rule. Now let us see about the union rule. In this rule, if x determines y and x determines z, then x must determines y and z. X determines y and x determines z, then x determines y and z. Okay, this is about union rule. Let us see decomposition rule. In this rule, x determines y and z, then x determines y and z separately. This is just separating both the terms. See, if x determines y and z, then x determines y and x determines z separately. This is about decomposition rule, as the name itself says it. pseudo transitivity rule. In this rule, if x determines y and yz determines a, then xz determines a. This is the expression form. If x determines a and yz determines, if x determines y and yz determines a, then x z determines a. This is the rule. We can't do anything else. You have to remember it. Okay, these are the 6 rules of axiom, access or interface rules in functional dependencies. Now let us see about the normalization. Okay, normalization is another topic where we have first normal forms. These are nothing but normal forms. We have 3 normal forms, and I'm going to tell you 3, and one more normal form is, that is boycott normal form, BCNF we will call it as. So I will discuss this in the next video. So to know about the normalization, you have to wait till my next video. So thank you for watching my video, and please don't forget to subscribe my channel, like and share it if it is necessary, and share it to your friends also. It may be useful for everyone, because I am providing you notes as well. You can easily learn it up. Okay, please note down the notes while I'm teaching only, so that it will be useful for your exams, semester exams, or it may be also useful for your gate exams. 1 or 2 bits may come in this rules which I have already told you. So please forward this to your friends, and don't forget to subscribe my channel. Thank you for watching. Bye bye.